Monday, we're just going to kind of review some of our algebra skills that we've learned in Algebra 1, and hopefully they'll settle in and be like, oh, okay, I can do this, all right? Helena? Now's my time. Okay, so when we are solving proofs, we want to make sure that you're working only on one side. Choose the more complex side to work on. You want to look for your algebraic manipulation. This is what we're going to focus on. Is algebraic manipulation. I know you guys are quick to tell me I didn't learn in algebra. So that's why we're going to reinforce some of those things that you say you did learn. Okay? And then we'll resume from there. So we're going to do number 1. So the first thing we're going to talk about is multiplying. Multiplication rule. Now I am hoping that you guys are okay with it. So bear with me. Before we do the trig, we're going to do an algebra problem like it. Okay? So in algebra, it was very common for you to see x plus 1 squared, right? Mm-hmm. In algebra 1, what did x plus 1 squared mean? You have 2 of them, right? Because it's squared. So that means that it's x plus 1 times x plus 1.
Out there was mine.
When it's squared, that means they're exactly the same. And then what was the process you would follow? FOIL. You would distribute, right? Mass distribution is like FOIL. Okay? So when you do FOIL, you do the first 2 terms, and that gives you x squared. You do the outside terms, and that gives you and then you do the inside terms, and then you do the outside term, right?
2.
And 1 times 1 is 1. It's all good.
It's gonna be x squared plus x squared plus 1.
And what is x squared plus x squared?
X to 4.
2x. If you have $1 and another dollar, you have $2.
I thought you said x squared plus x.
I said what's x plus x?
I heard x squared.
I did too. It's okay.
It's all right. No judging.
You did say x squared plus x squared.
No.
She said x squared plus x. I swear to God she did.
I know what tripping.
It's okay.
When it's over, I'll replay the video.
All right.
All right.
Cut it is not that serious.
It is.
All right. Here we go. So, the same thing we did here is the same thing we're going to do here. The only difference is instead of working with an x, you're working with tan theta. So, it says tan theta plus 1 squared. So that means I have how many of them? 2. So I have 2 tan theta plus, that's an interesting theta. It was a very interesting theta that came out.
It's gonna be tan theta squared.
So then, following that same process, if I look right here, this is going to be what I come down to, but instead of x's, what do I have? Tan. So it's going to become
tan theta squared.
Tan theta squared plus
tan theta.
I may have to. Plus 1. I'm going to do it.
This nigga ain't texting me back, bro.
Yes.
So then it would be 2 tan.
So then it becomes what? 2 tan theta in the middle.
I'm not going to open the plus sign on my
So we have tan squared theta plus 2 tan theta plus 1. And that would be my multiplied out answer. Okay? Did the process change from Algebra 1 to trig?
No.
No. Just the variables you're working with.
Okay, that's easy.
Watch be easy when she has practice.
We added this.
Alright? Mr. Williams, are you going to work with us today?
Ooh, hold on, go back. Please, real quick.
Sorry for disturbing you.
Yeah, you see?
My bad. Okay, so then we're going to do our next one. So the next thing we're going to review is...
Nobody even look at you.
You did. You look straight into my eyes. My I saw it.
So our next example,
She did that
and we
earlier.
have secant
Go
theta
for
plus
it.
tan theta plus secant theta minus tan theta. Okay?
Oh, shit.
So we're going to start with the algebra review of it. So in algebra, if you saw a problem that said x plus 2 times x minus 2, what did you do?
X plus B.
Anyone remembers?
Don't
Huh?
you equal them to 0?
No, you don't equal them to 0. You're
Would you add the 2 to that one?
Nope.
I don't know.
Okay? This is called difference of two squares. So if I have the same terms but opposite sides, that means that it reduces down to x squared minus, I didn't even write 4 squared. Let's write 2 squared. I need a 2. Minus 2 squared, which equals x squared minus 4. When the terms are the same and the operations are the opposite, it's a difference of 2 squares. That means that all that's going to happen is you have your FOIL, you're only doing the F and the L because the middle is going to cancel out. So first term to first term, last term to last term. And that's going to give you the x squared minus 2 squared. And what is 2 squared? 4. Right? You agree with that? Yes? No? Maybe so? Okay. The rule that you may have seen was A minus B times A plus B equals A squared minus B squared. That was your difference of 2 squares. Okay? So when I look here at the trig problem, do I have the same terms and opposite operations? Yes. So that means that this is going to condense down to my first term squared and my second term squared, which is tan squared theta. And that would be it. Following the algebra rules. What are your questions? Where's she from?
She's been on.
Really?
She just doesn't talk.
2.3.
Okay, questions about the difference of 2 squares? Okay, so when you are multiplying out, that's this process. What is the opposite of multiplying? Dividing. So when I'm multiplying out and then I can divide. When you're dividing, when you're undoing multiplication in an expression, that is your factoring. So now we're going to review factoring from Algebra Uno. So if I have sine squared minus cosine squared, I look at this and I'm like, this looks kind of familiar. Well, what does it look like? Well, if I, in Algebra 1, saw a problem that said x squared minus 4. And I'm like, how can I factor that? Well, this is a perfect square, this is a perfect square, and I'm finding their difference. So that means that I take the square root of each one, and I'm going to end up with x minus 2 times x plus 2. Because I'm undoing that difference of 2 squares. Do we see that? And the opposite of squaring something is to square root, right? Yes? No? Maybe so? So if I look right here, I have sine squared theta minus cosine squared theta, and I want to factor that. So that means what I did in algebra, I'm still going to do here. So I'm still going to take the square root of both terms. What's the square root of sine squared? Nobody? Sine. What's the square root of cosine squared? Cosine. So this would be 1, and then the other one would be? And that would be my factored solution. So you're just taking the algebra process and applying it to trigonometry.
Okay, no.
Don't try to be dramatic. What are your questions? Guys, if you don't ask me anything, I don't know if I should further elaborate.
It's like we don't know what to ask.
Miss, if
you
I
know what
traded
I'm
my
saying?
trip for Shelby.
Ignoring him. What do we have? None? No question.
Hold up.
What if when you come to tutoring, I'm like, well, why didn't you ask that question in class?
It's just like. It's just like. Oh,
I'm going to really repeat the same thing.
I forget.
Okay, so are you confused on taking the square root to get rid of the square? Or are you
I'm
confused
talking about
on...
tomorrow. Like, I'm getting it right now, but then tomorrow you come.
Okay. So that's why I'm here, because tomorrow I won't be here, and you'll have a sub and you'll have a worksheet doing this. So if you are confused, this is why we both know. I don't know why you smack your lips. Not you're gonna do anything. Okay. All right. Nope. It's a student activity that you're participating in. So you're a student, which means you still got to do student work. All right, cosine squared theta minus 2 cosine theta plus 1. So this came from us foiling, and we're going to undo the foil. So in algebra, what this would look like is if I had x squared minus 2x plus 1. And your teacher say, factor this. When you learn how to factor to factor this, you're asking yourself what multiplies to give you 1 and adds to give you 2. So you're looking for two magical numbers that will work in this situation. So what number multiplies to give me a positive 1, but adds to give me a negative 2? What two numbers?
1 and negative 1.
What kind of ones? They would both have to be negative ones, because a negative times a negative makes a positive 1, but a negative plus a negative is going to still be a negative. So it would be x minus 1, x minus 1.
Oh.
Can they be positives too?
Huh?
Can they be positives too?
No, because I wouldn't get a middle negative. If they were both positive, then my middle would also be positive. My b term would have to be a plus 2x. Okay? So because I have two of them, then it condenses down to x minus 1 squared would be its factor form. Yes, this looks familiar. Okay? Same process, but instead of for us using x, our x equals what? Our cosine theta, right? Because that's what's there in place of x, is cosine theta. So if I've already done this process, then I can just plug in cosine for x. So I know that it would be cosine theta minus 1 times cosine theta minus 1, because that x was there. Okay, cool. And so that means it condenses down to cosine squared theta minus, I didn't even write square there. And that would be the trig answer.
Oh, they stabbing people for real. I thought you was just playing.
All right. What are your questions?
Somebody got stabbed at the
Okay, so we're going to do another one. So let's talk about what this looks like as an algebra problem. So in algebra, if I asked you to factor 2 plus 2x, how would you factor that?
You said what?
If I asked you in algebra 1 or in algebra 2 to factor 2 plus 2x, what would you tell me to do?
Are you trying to use the A plus?
Factor is that I'm trying to find what do they have in common to make. I'm going to make a greatest common factor. Thank you.
GCF.
GCF. So the factoring method here is greatest common factor. What is the greatest common factor between these two terms? Reese. What is the greatest common factor between these two terms? 2. They both have a 2 in common, right? So when you're factoring, that means you're undoing multiplication, which means that you are dividing. So from each one of these terms, I can divide out a 2. So 2 gets kicked out the house. 2 divided by 2 is 1. 2x divided by 2 is x, because my 2's cancel out. And then this would be my factored answer. Algebra 1. How do we feel?
That's a long ass time.
Algebra 2. How do we feel? because it's still algebra.
Should have been
Look what we had.
Okay? So then when I work this one, and I have tan theta plus sine theta times tan theta, what would be the GCF between these two terms?
Tangent.
Tangent. So I would divide both terms by tangent.
Tangent get kicked out of the house, right?
Tangent gets kicked out the house.
So it's gonna be
What's tan divided by tan?
And
1. Anything divided by itself is 1. What happens here?
it's gonna be sin theta, so it's tan is gonna be kicked out.
Tans cancel. I forgot my theta. Let me squeeze it in there. Was that process any different than the algebra process?
No.
No, not at all. Okay? Our next factoring.
So is all we doing today is factoring?
No. So here's the algebra version of it. 1 minus x to the 4th. What do you see? I'm subtracting, and 1 and x to the 4th are perfect squares. So that means that I can use difference of squares. So I get 1 minus x squared. I got 1 plus x squared. And then what can I do? We're factoring, so we're undoing the FOIL. What do you notice right here? Is this still difference of perfect squares? Yeah, so that means that I can do it again. So I can take the square root of 1. Uh-oh. Take the square root of x squared. And what's the square root of 1? What's the square root of x squared? And then so I have the subtraction version of it and it's not sum of perfect squares, so the sum is just going to come on down. Because difference of 2 dots is how we started. Difference of 2 squares, and then we dots again. Difference of 2 squares. And then now I am done. So, when we do this in terms of trig, I'm going to break it down the same way that I did this. So if I have 1 minus sine to the 4,
Yeah, square.
I'm going to, again, take the square root,
So
and that's going to give me
1 minus sine squared.
1 minus sine squared and 1 plus sine squared. I'm just being lazy and I didn't write it. I'll write it in my phone. Okay, can I break it down any more by using difference of 2 squares?
Yeah.
So I can break it down again. Square root of 1 in.
1
Square root of sine squared.
sine
Sine theta.
plus, and then the regular one.
And then plus sine theta. And then
1 plus sine squared.
perfect. And I'm just bring down the 1 plus sine squared theta. Uh-oh. Shoot. Try to squeeze it in there. I'm gonna have to bring this bad boy down.
Phone, clean, game.
I thought there was a whole nother space over there. Darn computer. And then boom, bam, that's my, just put it in the back.
Is that all of the problem?
Huh?
That's all of the problem?
Well, this is the actual problem, but we reviewed the algebra first.
Oh.
But this is our actual problem.
How much is it?
Okay? The next type of problem that you're going to have tomorrow on your classwork, so you remember how on your work from Tuesday, you have to simplify it down? Well, tomorrow I'm giving you the answer, and you have to prove show that it's true. Okay? So you'll be given the answer, but your job is to show why it's the answer. Yes, no, maybe so?
Yes.
Alright, so let's look at an example of how that's gonna look. Uh-oh. So you look right here, we have tan x. So I'm going to prove that this is my answer.
Hold on. Oh.
Freeze.
I just want to write down what you're talking.
Huh? Okay, so what's the first thing I want to do with the left side? I don't want to flip it. I want to put things in terms of sine and cosine, right? So if I have tan x, what does tangent become in terms of sine and cosine?
Cosine.
In terms of sine and cosine, what can tan become?
X, Y, red.
In terms of sine and cosine.
Cosine.
If you look at your identities, they're right there, guys. Just gotta try.
Reciprocal identity?
It's a reciprocal identity. So no, it's a ratio. I lied.
Cotangent.
It's the 1 over cosine.
It's what?
1 over cosine theta.
Sine and cosine.
We should eat pizza.
What, like literally, look at your ratio identity.
I have a question. Where are you getting cosine from?
Oh, it's
From the identity.
sine theta over cosine theta?
There we go.
Yeah,
So
Chris.
tangent becomes sine theta divided by
Cosine theta.
cosine theta. And that's because it's a ratio identity. So looking at my identities, guys, that identity paper, you can use it on all quizzes and tests, but if you lose it, then you're SOL.
What identity paper?
The notes from Monday?
You said notes for Monday.
Okay? So how do you divide a fraction?
Keep, change, flip.
Keep, change, flip. So I'm going to keep the
The
sign.
other
Sorry, I changed my x's into thetas. I'm going to keep my numerator, change my operation, and flip my denominator. So instead of sine over 1, it becomes 1 over sine. And what happens next?
Sine cancels out.
My sine cancels out, and I'm left with 1 over, and cosine, 1 over cosine theta equals
Equals, seek,
secant theta. And my reasoning is
reciprocal.
reciprocal.
seek, and it's the same thing.
Yeah, theta and x are going to be the same thing,
So
right?
we just put yes next to it?
So therefore, true. Proved it. You saying true or false gives you 0 credit. What gives you credit is you working out why it's true or false.
Understand.
Overstood. That's for tomorrow, though, right?
Yes, it's true tomorrow.
Yeah.
Okay, so let's try another one. Chris, you still have a whole 2 minutes in class.
No, my
What did you
hand
roll?
right now.
You got 10 minutes?
Yes. So I want to prove that this is the answer.
Before you start writing, write
I didn't want to be in your own way. So that's fine.
Tan equals sine.
So I want to put tan and cotangent in terms of sine and
So it's
cosine.
sine theta
So tan
over
is what?
cosine. Sine theta over cosine theta, and then
Sine over cosine
the other one is cosine over sine.
plus cosine over sine. And we use our ratio identities, right?
Is that every time?
I mean, they're going to always equal that. Remember, identity means it's always true. Okay? How do you add when the denominators are not the same?
The bold.
The bold, like using our chopsticks.
Yeah.
So what is sine times sine?
Sine squared.
Sine squared. My rice is plus.
Plus
What is cosine times cosine?
cosine squared.
And then you're going to multiply your bold,
Cosine times sine.
and that's just cosine x. Cosine x times sine x.
Okay? Sine squared x plus cosine squared x. What is that?
What?
Look at your identities. Sine squared x plus cosine squared x.
How does paper look?
It says 8 trig identities on it. Anyone? Sine squared x plus cosine squared x.
Sine squared. Oh, it's over here.
I heard it.
1.
1. That's because it's a Pythagorean. So my Pythagorean identity tells me that my whole numerator becomes a 1. Okay? And so therefore I end up with 1 over cosine x times 1 over sine x. And what is 1 over cosine?
1 over cosine is sec.
Is secant x. Good job, Chris. And what is 1 over sine?
1 over sine is cosec.
And boom, bam, we've proven that they're equivalent. And we went from here to here because of the reciprocal identity.
You had the, yeah, I know what you did.
So let's talk about what we did here. So we first chose to use the ratio identity, and that gave us sine x over cosine x plus cosine over sine x. Our denominators weren't the same, so we crossed and multiplied essentially to find common denominator. And we end up with sine squared x plus cosine squared x over cosine x times sine x. We then use the Pythagorean identity to condense our numerator down to 1. And then we wrote our expression as 2 separate expressions.
Miss, hold on, after, like, how do you know that Pythagorean was 1 over cosine?
Well, the Pythagorean is sine squared plus cosine squared equals 1.
Yeah. Oh, okay.
So it became a 1.
Yeah.
And then therefore we separated them, and 1 over cosine is secant, 1 over sine is cosecant. That's our reciprocal identity.
Tomorrow I'm gonna try to remember.
So it would be a true statement. Question. All right.
Another one?
Yeah, practice is the only way you're gonna get it. All right. So we're trying to get down to this. Okay, so I have 1 plus 10 x squared times cosine squared x.
This pretty too far would be right.
Maybe. Okay, what does this square mean? We did this. What does this square mean?
You gotta,
Do it twice.
I multiply it by twice, so we know that's going to come out to be 1 plus tan, 2 tan x plus tan squared x. Am I right or wrong? I already did it. And now I have cosine squared x on the outside. Okay, what does it mean when you have something on the outside?
multiply.
You're going to need to do what?
Multiply, right?
Multiply. So I need to distribute. Distribute, distribute, distribute. It doesn't matter if it's on the front or on the back of the expression. So cosine squared times 1 is cosine squared x. Cosine squared times 2 tan x is 2 tan x times cosine squared x plus tan squared x times cosine squared x.
You sending out these notes today, right?
So, next thing is you want to put everything in terms of sine and cosine. Well, cosine is already itself.
Tan is
Tan is going to become
sine of cosine.
sine over cosine. And tan squared is going to become sine squared over cosine squared. Okay? So now I'm in a position where I can eliminate. So I have a cosine here, that eliminates that. I have cosine squared, cosine squared. So I distribute. I then rewrote as in terms of sine and cosine using ratio identities. Ms. Jones? Yeah, because I know she's missing notes today.
Okay.
Alright, so now I'm going to write what I have left. So I have cosine squared x plus 2 sine x plus sine squared x. If you look right here, I have cosine squared x and I have sine squared x. What do they make together? What do we say sine squared plus cosine squared equals? 1. It equals 1.
So 1 plus 2 is
Oh, I forgot my little cosine here.
so it's right.
So therefore it is
It's good.
2.
My eyes hurt. They like to write.
You always see me talking that shit. She didn't even.
So there.
What?